So in this example, we have selling price versus age of car. And once again, we're going to ask which is the independent variable and the dependent variable. Pause the video and see what you come up with. In this case here, the selling price is based on the age of the car. So the age of the car is your independent variable, selling price is your dependent. Okay, create the scatter plot for the data. I'm going to come back to that. I'm going to save that for the end. I'm going to ask that you take this data set and enter it in so we can determine the correlation coefficient rounded to 4 decimal places. Take some time to put that into your calculator and see what you get. So if I was starting this from scratch, I would go second data, second clear, and then I'd put in 4, enter, and so on and so forth. If you overshoot by, you put an extra 0 or a different value here, if you use this arrow button, it'll scroll over so you don't have to clear and re-enter the data. And then you hit enter, scroll down, 7 years, 6,000, enter, 12 years, 2,000, 2 years, 12,000, 7 years, 6,000, 8 years, 7,600, 11 years, 3,000, 10 years, 4,000, 12 years, 2,500, and then 6 years is 8,000, and then 6 years is 84,000 or 8,400. 8,400. There we go. Once again, I'm going to check my data for 11,000, 7, 6,000, 12, 2,000, 2, 12,000, and so on and so forth. Like I said, you don't want to lose any marks by not having correct data in there. All right, so to find the correlation coefficient, go second stat, and these are where all the important values come from. And once again, 11 data points. We have 11 data points. You know you entered things correctly. At least you're on the right path. And you can see in this case that our value is negative 0.97 and change, so very strong negative correlation. So at 4 decimal places, it's negative 0.9741. And what does this mean? It's a strong negative correlation. And what that really means is that as age increases, goes up, price of the car decreases, goes down. Next it asks, determine the regression equation rounded to 4 decimal places and explain your findings. So once again in our calculator, if we scroll down, or sorry, scroll up, we want our A and B. All right, so remember this is, the B is your slope. So the equation then in this case is y is equal to negative 1003.681507x, and A Okay, your slope and y-intercept. Once again, everything rounded to 4 decimal places gives us 1,003,6815 x plus 14,164,8116, 4 decimal places. Next, what does it ask? Predict the price of the age if the predict the price if the age of the car is 9 years old. Okay, so I'm going to just make use of our calculator this time and say if when x is 9, y is equal to. So we put 9, enter, scroll down and compute, and we should expect the price of the car to be 5,131 and change. Okay. Now, once again, just make sure whatever I ask you to round, just round accordingly, but it's that simple. If you use the formula, once again, we would just plug in the 9 in for x, and we should get the same value. Now, let's go back to our data set, and let's put that into Excel, and let's just see how this corresponds with the chart. So here's our data set, and once again, I'm going to put the x on top so that Excel is not thinking for me. Control X, and I'm going to put that down here. Okay, so the age of the car is first. That's going to make it independent, putting it along the x-axis, and then the price of the car will go along the y-axis. Select your data, insert, scatter plot, and once again I'm going to put the important information, axis titles, so that's age, right? Age of car, and we'll say years. The Y labels is the price in dollars. And the title is age versus selling price. We have that, and then I'm going to move the chart to its own location, age versus price chart. And there we go. We have our chart. We can take this and right click it and copy it and put it into a document. But before we do that, I'm going to put the trend line in once again. So according to this, if I go to my point and I right click, I'm going to add the trend line. I've selected linear, or it's automatically selected the linear. Display the equation and the r squared value, which is the coefficient of determination, remember? I'm going to make this a little bit bigger. There we go. And then I'm going to move this. Now my computer's acting all funny, but there we go. I'm going to move that up here, and there we go. Now it's rounded it to 1 decimal place and no decimal places for the y-intercept. Now I just want to mention as well that we are bound by the value 2 and 12. Our data set only has those values, and so if we look at our data set, 2 is the smallest value and 12 is the maximum value. So when we actually look at the chart, the line is only going to be between 2 for x and 12 for y. But if we were to extend this line further, you see it does actually hit the 14,165 mark. So that's what that really represents. If this went up here, it's going to hit the y-axis at that point, at 14,000 and change. With that said, you should be able to input the data, determine the equation of the line of best fit, and as well put the data into the calculator to get all the other values, the R value and your R squared value, and interpret what those values are. It's pretty straightforward. What we're going to do next is we're going to look at determining the range of values, a confidence interval, when we predict at a certain value of x. So that's where we're going, and that's very useful when it comes to making use of this trend line. But that said, try the homework. I'm sure you'll have no problem at all if you can use your calculator properly. Have fun.